3 Lesson 9, Representing, Naming, and Evaluating Functions. The instructional outcomes are to understand that a function from one set to another set assigns each element of the domain to exactly one element of the range, and the second one is to evaluate functions for inputs in their domains. So there was a basic opening exercise that was done in class. It looked like this. It's really elementary for the most part, but it gives you an idea of what happens. So it says to match each picture to the correct word by drawing an arrow from the word to the picture, or vice versa. So, we have right here our elephant. So obviously this would be our elephant. This would be our camel. This guy over here would be our polar bear. And this would be our zebra. This is an early indication model to make you understand that there's only one thing that we recognize to be an elephant, there's only one thing that we recognize to be a camel, and so forth. We don't have any confusion as to what that type of animal is. So there's a picture or an animal that associates itself with that given name, and there's only one thing in our world that associates with that name, and that's the idea we want you to get with this idea as we start to talk about this notion of functions and domain and range and everything else that comes into play. So we'll start with a few definitions, and really the definitions is what you need to get through this. The first one says to deal with the idea of a function. So a function, by definition, is a correspondence between two sets, two different pieces of information. For us, in the previous example, that was the names of the animals and the pictures that they match. So an X and a Y, in which each element of X is matched to only one element of the Y. We have also an alternate saying that you might want to note just for learning sakes that's not usually said in the class, and that's to be a function, the x's cannot repeat. Now, that's not a formal definition as what's written above, but it is a good way to look at it and start to think if you're struggling with the concept and you're at least trying to get a place to grab a foothold and start. So again, to be a function, the x's cannot repeat. So we have to understand what are the x's and what are the y's. In our next definition, the set x is called the domain. And then, so we'll underline x and we'll underline domain. And then if we look at set y and then range, the x, comma, y. These are our x's and these are our y's for each one of these particular pieces of information. Set notation, this is a mapping piece. That means this x maps to this y. So for example, if I said, for example, as a basic example, 4, comma 3, then the 4 belongs to the 3. And so if I put another one on there that said 1, comma 5, then we would also say that the 1 maps to the 5. That's looking at a very basic idea, just to give you an idea that something belongs to another in those particular pieces. It also brings up in this set of definitions this notion of f of x. For the lack of a better idea for right now, just associate f of x as y. So f of x is equal to y. They're the same thing. And this is noted as f of x when you pronounce it. So f of x. So going back and looking at our example that we looked at with the pictures of the animals and the names of the animals that we defined, they want us to be able to state the domain and then the range. So when we write that, or to write a function notation, we would say that the function, and so if we're looking at different things, the animals pictured, belongs to the animal's name, or the words listed. So we map one to the other, whereas this would be our x, and this would be our y over there to the right. That mapping piece. One thing belongs to another piece. So if we want to state our domain, remember, domain are the x's, and in this case we represent our x's as the animals pictured, and the range, which which is denoted by Y, as the words listed. So this would be our domain, or basically what's known as our X's, and our range, which is typically known as our Y's. So they give us example number 2. Is the assignment of students to English teachers an example of a function? If yes, define the function notation and then state the domain and the range. So we'll start by answering the question, is it a function or not? And the answer will be yes, because if we take and we assign students, which will be our domain, to English teachers, which will be our range, each student is going to get one teacher. Typically in a grade level, 9th, 10th, 11th, or 12th, take your pick, you're only going to have one English teacher that year, so you're only assigned to one English teacher, not multiple English teachers in that time frame. So if we want to write it in function notation, what are we defining as our domain? That would be the students in class. And that's assigned to an English teacher. They want us to state the domain and the range, so here's our domain. I'll just draw an arrow to it. Right here is our domain, and right here is our ranges. Now, looking more specifically at numbers, because of course this is a math class that you're taking, and we don't study English teachers and students assigned to those and things like that very often. So we want to look at and associate some numbers. So here we are, they tell us the X's, which is our domain. So we'll make a little note that that's our domain, is 1, 2, 3, and 4, and our Y's are, which is our range, which is 5, 6, 7, 8, and then 9. F and G are defined below as such. So they tell us in our function F, these X's maps to the Y's, so 1, 7, 2, 5, 3, 6, and 4, 7. And in this one over here for X to Y for G, function G, 1 maps to 5, 2 maps to 6, 1 maps to 8, 2 maps to 9, and 3 maps to 7. So they're asking us in their first one, is F a function? If yes, what is the domain and what is the range? If no, explain why F is not a function. So let's first look at that, and let's remember our definition. In order to be a function, in the simplest terms, the X's cannot repeat. So if we look at our F functions, we have a 1, a 2, a 3, and a 4. So none of the X values repeated, so therefore we would say yes, F is a function. If it is a function, what is the domain and the range? Well, the domain is the list of our X's, so 1, 2, 3, and then 4, and then our range is listed as our 5, 6, and then 7 is our range, is those 3 values right there. If we look at the next question, they say, is G a function? So we'll take a look at G and we'll compare. G has a 1, a 2, a 1, a 2, and then a 3. So G is not a function. And the reason why is that X values repeated. Now, if we want the technical definition, we would say that the domain mapped to more than one Y value. And we don't want that to be the case. In other words, you can't map a 1 to a 5 and then turn around and map it to an 8. It can't belong to both in that particular instance. So if we look at exercise number 1, these are some of the things that you would have practiced in class, probably in pairs. And so it says define F to assign each student at your school a unique ID number. So here we are, the students in the school listed as our domain. and then the whole numbers that are in the list. So the first thing, is it an example of a function? Why or why not? We would say yes, because if we are in a school and we're assigning all the students in the school a unique ID number, then my ID number as a student or your ID number as a student will not be the same. You and I cannot have the same ID number. So we would say yes, we all have unique ID numbers. So this says, suppose the function of Hilda equals 350123. What does this mean? It simply means that Hilda's ID number is 350123. And then, they say this one, write your name and student ID number using the function notation. And so, we'll just make something up. Let's just say if this is the function of, we take a student named John. Well, John's ID number might be 615328. And so you make up whatever you want. It's just taking an opportunity for you to have a turn to write something that would look like what we just practiced. In exercise number 2, it says, let G assign each student at your school to a grade level. Is this an example of a function? Explain your reasoning. So again, this would be yes. And the reason why is students are, make that R a little bit better, are assigned only one grade level at a time. Or in other words, if I'm coming to the school, I can't be both in the 9th grade and the 10th grade at the same time. So with that being the case, it makes it a function. Each student only goes to one grade rather than multiple grades at one time. So we say for the domain, express the function notation using domain and range. So the domain, that would be the list of all students that are in the school. Now the range, if we're talking about high school, can only be one of 4 things. They are either in the 9th grade, 10th grade, 11th grade, or 12th grade. So that would be our range. That's the only results that we can get, the only places we could list or map each student in the high school to. And so that's where we would stop at in that given instant case. In this particular piece, we expand on that. Student ID number and grade level, so describe the domain and the range of the function. So the domain, that would be the ID numbers. And again, the range for high school purposes, 9, 10, 11, and then 12. So in part B, they just say record several ordered pairs f, x, f of x that represents yourself and students in your group of class. So you would have an opportunity to pick certain things. So like just an example, one ID number might be 4, 5, 6, 7, 8, 9, and that person might be assigned to the 12th grade. Or you might say 1, 2, whoops, let's back that up. ID number 1, 2, 3, 4, 5, 6 might be assigned to 10th grade. And so this just gives you the idea to practice and realize that this is our x's or our domains, and these are our y values, which is known as our range.